All right, cool. All right, so hello everyone. Welcome to week five. I mean, not week five. Getting ahead of myself. Week four of this class. If you haven't already, please fill out the attendance form or the absence form if you're watching this later. Um, I think we're missing a couple submissions from the last few weeks, so I'll send a message about that later. But today, we're going to be starting to get into more of the 3D printing side of this course. So you're going to learn about slicers and stuff like that, and just also a little bit of like 3D printing history. Um, but yeah, let's just get started today. One thing I didn't really mention last week was your final. So this class does have a final if you didn't know. But don't be like frightened or anything. It's really not that bad. Um, you're just going to utilize all the skills that you've learned in this class to create your own model. Obviously, it can't be something that we've done in class already, like the engineering fountain or something like that. But you're more than welcome to make, anything school appropriate, preferably. Um, and in the end, you will have the option to print it. So I'm actually printing the finals from the last session as we speak. But the main thing is just have more than five design features. So like, you know, have a couple extrusions, revolves, and fillets. Again, five is really not that high of a number. Like we've gotten pretty close to five in some of our assignments. So if you do your own thing, make your own model, it shouldn't be too big of a deal at all. But the other thing we want you to do is to kind of design it with manufacturability in mind. This is for both your benefit and my benefit because one, it teaches you how to design something to be made practically. And two, it also makes my life easier when making and printing your finals. So I'm going to be talking about stuff like bridging and overhangs today. So if you don't know what it is, don't worry. It's just going to be a lot of 3D printer talk. So hopefully by the end of today, you'll kind of have a good idea of how you should start designing things. Obviously, there's a bunch of different techniques that you can use, but I'm just going to kind of give you an overview so you can start thinking about that when designing your things. Um, Also, if you ever have any questions about your final, like, oh, it's like, is this like manufacturable? Then feel free to like send me a photo or something. I'm happy to give feedback. So yeah, that's your final. And then also you're going to be rendering that your final, but we're going to be going over that next week. And again, yeah, here's some photos of past finals. Obviously, all these photos are Um, these all utilize more than one or more than five design features. So if you have, some extra time on your hands or you just want to go all out to kind of show me what you've learned, I highly encourage that. But I know everyone's busy students, so I totally understand if you have a little bit of less time, and just wanted to make something a little simpler. But yeah, today we're just going to be going over 3D printing, like I was saying. So I'm going to be talking a little bit about manufacturing. So typically, when people think of like machining and manufacturing, a lot of the times people think about subtractive manufacturing, and that's basically what people have been using for a really long time, where they basically take some kind of object and then they take stuff away from it until they get the shape that they desire, right? So from this like diagram you can see on the left, there's a tool and like a big solid block of something. And then that tool carves away at it slowly over time. And then eventually you are given a finished product, right? And stuff like drilling and milling and turning uh, are all subtractive processes. So if you look over here, these are some common ones. Obviously, like I said, drilling, milling, and turning are pretty common. But stuff like routing and grinding is also subtractive, right? You could even consider something like sanding a subtractive process because you're taking stuff away, right? And you know, subtractive processes are great and all, but they can be a little bit wasteful because again, you're taking that big block and then turning it into something smaller. So there's a lot of chips or waste involved with this. But that's what we've been using for a really long time. Um, Obviously, there's some advantages and disadvantages to it. A lot of the times you can use really strong materials like aluminum and steel and titanium and all that fun stuff. But there's also other manufacturing processes available to us these days. And the other one is additive. So it's just the opposite of subtractive, right? You start with nothing, but then you have some kind of tool that over time grows your part into the end product that you desire, right? So there's a nozzle here on the left on this, extruding onto this plate. And then over time, it creates a very similar object. So a lot of the times when we say additive manufacturing, we refer to like 3D printing, but there actually is, more than just 3D printing available to us. Um, the biggest one is actually injection molding, because if you think about it, you have a mold, and then you inject a material into it, right? You add material, and then you spit it out, right? So that is an additive process because you're adding that material, in many cases plastic, into a mold to get your desired part. But today we're mostly going to be talking about 3D printing, just because it's a tool that's readily available to us as students, especially in the last couple of years. 3D printing has gotten very accessible to everyone, where you might know someone who has a 3D printer either in their dorm or in their house or something. So it's a pretty great time to be alive, to have all this technology available to us. So I'm going to talk about it today, and we can hopefully utilize it in the future. So obviously, there's a bunch of applications for 3D printing. I actually use 3D printing where I'm interning right now, and it's pretty great because it's great for rapid prototyping, right? So there might be something that could be made out of metal in the future, but to get an idea of what we want, we can make multiple iterations pretty quickly with 3D printing, which is really, really nice. Also, compared to like a big piece of metal, 3D printing a part is so much cheaper and just a lot faster because you don't have to send it out to a machine shop to get machined and then sent back. You can just have your printer at your work, just print a model out, just test it, and then see where you want to go from there. Um, there's a bunch of other applications. You'll find it in automotive components sometimes. I know Porsche for like some of their very high performance vehicles, they've done like 3D printed pistons, because it allowed them to reduce the moving mass to get more RPM and more power, which is pretty cool. Aerospace is another great application, just because you can get a lot of complex shapes, and remove a lot of weight that's unnecessary when you're flying, um, or sending objects into space, right? Um, People have 3D printed houses with like concrete and stuff like that, which is pretty cool. And then there's also some bioprinting going on, they're trying to print like tissue cells and all that fun stuff. Um, Also, there's, jewelry and clothing and art that 3D printing is a big part of. A lot of people, 3D print trinkets and stuff like that and put it around their house. So it's pretty great. And you can also 3D print food. So I know, I believe like astronauts have like a 3D printer that prints like a pizza or something. But people print like pancakes and chocolate um, here too, which is pretty cool. But yeah, there's a bunch of different types of 3D printing. I'm not listing all of them here, but some of the common ones are like SLS and SLA. So SLS is a little bit more industrial compared to what we're going to be mainly talking about today, but I think it's pretty cool. Um, they basically use a powder and a laser. So they shoot a laser at the powder and it melts it. And then they cover the powder with some more powder. And then they continuously, shoot lasers and add more powder on top of it until you have a fully 3D printed part. One of the advantages to something like this is that um, you don't need supports, which we'll be talking about a little bit later, because the powder around your model will support your piece as it's made, which is pretty cool. Um, and generally, SLS parts are actually pretty strong. Um, SLA is another type of 3D printing where they use a resin. So it's kind of like an epoxy that's um, that hardens with UV light, and they have a display on the bottom which shines a light at a very specific, um, you know, in a very specific way that outlines the part that you're trying to make, and it'll shine that light. It'll cure the resin a little bit, the build plate will move up, and then it'll continue that process until you have a part. So it's pretty cool. These two processes are pretty awesome. But the main one that we're going to be talking about, and the one that you might be most familiar with, is fused deposition modeling, or fused filament fabrication, depending on which trademark you want to go off of. But basically, it uses a filament that goes through some kind of heater to create your part, right? So the way I like to describe it to people is it's basically like a very fancy hot glue gun that extrudes plastic instead of glue. And then it's connected to a gantry or a robot to control and precisely deposit the material, right? So here in this diagram, you can see there's, some kind of mechanism that pushes the filament through the heater, and then the filament exits the nozzle where it's laid down on layers and layers until you get a fully 3D printed part. So 3D printing is pretty cool. And one of the big advantages to it is that you don't really need any additional tooling to make complex geometries. So if you've ever like manufactured parts on like a mill or a lathe, you'll probably come to realize that if you want to make a shape that's really complex, you'll either need to like take the part out and rotate it or something, or have some very advanced machine that can move in multiple axes. Um, that, or you have to have additional tooling to, hold the part the way you want it. Um, but with 3D printing, all of that stuff is basically eliminated because it just can make the part in almost any way that you want. Um, and it's pretty cheap in comparison. So we're going to be talking a little bit about the settings here. They do get a little nitty gritty, so please bear with me. Um, a lot of these settings can affect the way that your part, um, you know, your part's strength or its weight. So all of these settings, should be changed depending on your use case, right? The cool thing about 3D printing is that it's extremely flexible, but with that flexibility comes, a little bit of a burden of knowledge, because you need to remember all of these things when you're making it, so you get the desired properties that you want in the end. So to start with, I'm going to be talking about layer height and perimeters. So the layer height is basically the first thing that you'll change whenever you're 3D printing stuff. To be honest, I kind of just like set my layer height to just like one height, and I use it for almost everything. Um, but the layer height can greatly affect how strong or um, how fast your print will be produced. Um, so if you've ever used a printer and you've like messed with like DPI, I'm talking about a 2D printer right now. The DPI is like kind of it stands for dots per inch. I think dots per square inch. So um, if you increase the DPI, you'll increase the resolution and your print will come out, a lot more smooth and defined. Um, Layer height is very similar to DPI in that aspect, but it's in 3D, right? So you can change your resolution from like a high to low resolution depending on what you're going after. And the biggest trade-off you're going to be getting is speed and surface quality. So on the left here, you can see there's this part was printed with like a 0.8 millimeter layer height, which means every layer that the printer like prints is 0.8 millimeters. A little self-explanatory. But you can see like visually, you can see the layer heights or the layer lines along the surface of the part. And depending on what you're going for, that might be a desired trait. It might not be. Um, but generally, if you increase the layer height to be taller, your print time will go down just because there's less movements for your printer to make. Um, but then, you'll sacrifice some resolution, right? If you're making like a really fine model, like let's say you wanted to print like a really detailed figurine for like your D&D sessions or something, if you printed with a really high layer height, like a 0.8 millimeter height, then, some really small fine details might be lost. Um, that being said, if you went further to the right and made your layers really fine, you could kind of get that resolution that you're looking for. Sorry, I'm reading the comments real quick. Okay, I'm gonna answer some of these questions. Some of them are unrelated to what I'm talking about right now. Uh, are we allowed to use colors and textures? I'm assuming that's for the final, and the answer is yes. Um, the final project is due 1 week from the last class. Sorry, I didn't see the chat until now. So yeah, if you're wondering, the final is due like the Tuesday after the last class. So the last class is the 12th, I believe. Yeah, so finals will be due on the 19th. Sorry about that. Anyways, oops. So as you go and get a finer layer height, the prints will come out looking a lot nicer. But you'll sacrifice time just because there's more layers to print. Um, Typically for me, I usually print at a 0.2 millimeter layer height. And I find like that's a happy medium for um, speed and also quality. Um, I talk about strength when I talk about layer height a little bit, just because prints are weakest along the layers. So, like if a part were to break, it's very likely that it's going to break along a layer line. So the more layers you have, um, the weaker the part is. So if you have a really fine layers, then there's just more points of failure for the part to break. Obviously, depending on your use case, this may not matter, but I guess it's something to keep in mind. Next, we're talking about perimeters. So perimeters is basically just how thick the wall on the outside is. So obviously, if you have a thicker wall, it'll be stronger, but it'll take more time to print. So, again, a lot of these have trade backs. So with more perimeters, get more strength, but it takes more time. So for me personally, I usually keep my perimeters around 3 to 4. If I'm printing, something that I want to be really strong, I might increase it all the way to like 6 or 8. Um, but perimeters is a really good way to increase the strength of your part. Um, we're going to be talking about infill in a little bit. But for me, I find that increasing perimeters before increasing infill usually makes the part stronger, like by weight and also by speed, um, or the speed at which these parts are printed. Um, so yeah. Infill is basically just how dense the inside of the part is. So if you didn't know, a lot of parts on 3D printers are actually hollow. So typically I use like anywhere from like 15 to 25% infill for my parts because a lot of that like mass and material on the inside doesn't really contribute that much to strength, right? So it helps with structure, obviously, a little bit. But there is a point where, you're not gaining as much by adding more infill, which is why I recommend increasing perimeters if you want more strength, before you increase infill. Obviously, you might want to change or increase both of them at the same time. If you had to change one, perimeters would likely increase the strength the most. Obviously, if you increase the infill, it'll increase the print time and cost of your part just because you're depositing more material. But if you really need that extra strength, then this might be a way to get it. Underneath that, there are supports. So um, supports is kind of one of the limitations of 3D printing. Obviously, printers are limited by like the laws of physics and therefore gravity. So when it prints things, it can't print things in midair, or if it can, it'll have very like high difficulties. It'll have a high difficulty printing things in midair, if that makes sense. Um, so to combat this, some people, really smart designers, uh, figured that you could print sacrificial material to hold up a part that might need a little bit extra help to get there. So if you look in this model down here, we have this cylinder going out to the side, and obviously, it's just sticking out. There's nothing underneath it. To reproduce this, you need to have something supporting it underneath. So that's where these supports come in. So once this is finished printing, you just kind of break them off, and then you have your part. The nice thing, now that you know how to design things, is that you can try to design supports away. Obviously, it doesn't work in every scenario, but because you have the power to control the design, you can try to think of ways that you may uh, think of ways to design your part so that you don't need supports. So in this case, because they want a cylinder going out in this direction, might be a little bit harder to um, design out. But if there's a way, I really recommend you try to do that when designing for 3D printed parts. So yeah, here's another example of supports. You can see like the H and the T have these overhangs. So the T needs to be supported if it's going to be printed that way. Obviously, if you were to print the T facing down, then you wouldn't need it. So print orientation might be something to consider when designing stuff. This H, honestly, in modern times, it may not need it depending on how big it is. But then again, you could just print it flat on its face and you'd have no issues. Um, so you can use supports when needed, but generally it's recommended to avoid it just because as material, especially material that's going to be wasted, and then it also adds, print time and also, it'll require you to post process the part once you finish printing it, right? You're gonna have to remove it. Um, for one piece, it may not really matter. But if you were designing something that was going to be printed like 100 times, if there was a way to design out the supports, you could probably be saving yourself a good amount of money and time. So, good thing to keep in mind when designing stuff. All right, now that all of you are probably fast asleep, we're now going to be slicing our parts on our own. So I know I was rambling a lot, but if slice your own part, you might start to get a better understanding on what all these parameters do. So to do that, we're going to install a slicer software. It's completely free. It's called Prusa Slicer. So let's do that now. So if you go into the Discord and go under resources, there's this link here to Prusa Slicer. Uh, it's an open source software that you can download and use to slice 3D models. Um, so, you just download it here and then open it up. I've already downloaded it, but I'll just do it again. I think mine's due for an update anyways. So you just kind of run through this. I have one open. All right. So once you download it uh, and open it, you should be greeted with a window. Open up. Done. Okay, here we go. So once you download Prusa Slicer, you should be kind of greeted with a window like this. Uh, is everyone with me? Is all the software downloaded? If you haven't, then let me know. Okay, I see one thumbs up, so that is good to hear or good to see. Cool. Two thumbs up. Awesome. So I'm just gonna assume everyone's on the right track or they're almost there. But you're gonna be greeted with like this wizard just to kind of go through and stuff like that. It might ask you to log in. I'm just gonna skip that for now. It's totally optional. Um, just gonna click next if it loads. Okay, cool. So then you'll be greeted with kind of like a selection of all of the different machines. Um, you're going to be greeted with all the Prusa machines just because this is the Prusa software. But you can also add, third-party machines or even custom machines to this program. Today, I'm just going to tell you to use the Mark IV-S with the zero point 0.4 high flow nozzle. It's just kind of like, a solid default printer that we're going to use to slice stuff. And if you use that printer, you know, we can compare, slices and make sure it's all the same. Obviously, this isn't the only printer that you can slice stuff with, but that's what we're going to be using today. So it should look like this, and it should be on the top left. It'll say input shaper, and then, the high flow is 0.4 millimeter nozzle. So with that, I think you can usually just press finish, but you know, it'll also allow you to select other printers that you may already have. Personally, I have a bunch of printers, so um, it'll ask me more stuff. It might take you down to filaments. We're just going to be using PETG today, just to slice. So it's going to be set to generic PETG, but I'll go over the interface in a little bit. If you were having trouble finding a filament, then it would probably be somewhere in here. But yeah, you can click through this or you can just press finish. I'm just going to press finish. Um, for the view mode, you can leave it in simple mode for now. I'll put it back in simple mode, but I have it, I usually have it as like the highest just because I have access to more settings. Anyways, I'll set it back to beginner. So similar to Fusion, there's a really big workspace where you can, insert parts and stuff like that. So this is what, I call the build plate, right? This is just like a virtual representation of the platform that your printer is going to be printing off of. So, that's where you place your parts and then slice them. So, to move around, you just use the left click button. I believe if you right click, you can kind of pan left and right. And then you can also zoom in and out with the scroll wheel, just like Fusion. On the right, you'll see a couple of the settings that we were talking about earlier. The top one is the print settings, but it's actually just the layer height. So over here, you can see there's a couple different like profiles that you can choose from. Um, yeah, you don't have to sign in. It's like this is completely separate from like Autodesk and stuff like that. Anyways, so here, here's the layer heights or like your resolution on like the vertical axis. So you can change that here. Below it is setting your filament type. So we're not going to be talking much about filaments today, but there's a bunch of them out there. This is, where you can specify what you're using. Um, let's just stick with generic PETG today, because your filament type can affect print times a little bit. Obviously, underneath we have the printer selection. In our case, we have the original. Prusa Mark IV with input shaper, running a 0.4 millimeter nozzle. Um, oh wait, no, should be this one. It should be the Mark 4S with the high flow 0.4 nozzle. Um, you know, when you open this drop down, your thing probably won't be as populated as mine. But just because I've had many printers and stuff like that, I keep a lot of the presets here. So that's why mine's so large. Underneath is where you can enable like supports. So uh, like on here with that cylinder and that's like blue support material. That's where you turn it on here. You can also specify your infill right underneath it. Obviously, these aren't all the settings that you can change. If you want to go and get more settings, you can go under the print settings here on the top left. So we're going to move away from the platter and go to the print settings. Um, at layers and perimeters, you can also specify your layer height here, or you can change the number of perimeters. When you set your layer height, I honestly recommend you use one of the system presets, just because it might change things like speed and stuff like that with it. So I usually leave those alone. And the main thing I would change here is just perimeters. Uh, there's a couple more settings here, but these are a little bit more nitty-gritty, like how many layers or solid layers you want on the top and bottom and stuff like that. But you know, I usually just kind of leave these alone, but if you did want to specify it, that's where you can do it. You can also change the infill here and also the infill type. So there's a bunch of different like patterns that you can use for your infill, but just leave it at grid for now because that's pretty standard. Again, for this, we're going to be having a slicing assignment, so you want to make sure all the settings are kind of the same and correct, just so you'll get the same time as I do. There's a couple more settings like a skirt and a brim, but for the most part, you don't really need these settings. Skirts and or mostly brims are used if you have a part that has like a really small surface contact with um, with the bed that you're printing off of. So like I don't know if you're printing like a chopstick vertically, right? It's a really tall print, but the surface area would be really tiny. Did I change any settings? I haven't changed any settings yet, but I'm going to be changing them in a little bit. Yeah, if you had, like that chopstick, like I was talking about, um, it has a very small surface area in relation to how big the part is. So, that might be when you want to turn on like a brim. So the brim will kind of print like a pad around the bottom or the base, just so the chance that the print falls off might kind of go down. Uh, if you're asking what printer you should be using, let me go back. You should be using the Mark 4S with input shaper, uh, and the high flow and 0.4 millimeter nozzle. So let me open it up again. Usually when you open this, it takes a while, so let's give it a second. Yeah, should be Mark 4S with the high flow or 0.4 millimeter nozzle. You just click that checks box. Okay. The last one here is just like where you can enable support material. I always leave like the auto-generated supports on for the most part. Um, but if you want it to be like specific, You could turn it off and set it manually. So yeah, that's just kind of an overview of the UI for Prusa Slicer. Um, all that's next to do is just to slice apart. So So for assignment 9, we're going to be slicing a benchy. So if you don't know what a benchy is, it's a pretty classic 3D model that a lot of people printing use. And it's basically like a torture test um, infused with a funny looking boat. It has a bunch of geometries that can be difficult for a printer to produce. Like the hull has like a really steep overhang, which we're going to be talking about later. There's going to be a lot of bridging and stuff like that. So generally, if you can print a good benchy, then you can also print, other models with decent quality. So we're going to print a benchy today or slice a benchy today. And to do that, we just need to find a benchy. Um, so I'm going to go on Google and just find one real quick. If I can type. There's like a whole like Benchy website where you can download it. There it is. So I'm going to go to Thingiverse, but you can see there's a bunch of different places where you can download it from, and I'm going to download it. So I'm going to just download the first one, 3dbenchy.stl. Going to download it. I've already downloaded it, which is why it has that one. But this website, Thingiverse, is very similar to GrabCAD and stuff like that. It's an online repository where you can, post models and download models for free. So now that I've downloaded it, I'm just going to insert the part. There's a bunch of ways to do it. You can like drag and drop from your file explorer. I believe you can go under file and then import again. But for me, I just do Control I or Command I if you're on Mac. And then, you'll find the part and then open it.
Can you try to get like download that Benchy again?
Yeah, sure. So you can just go straight to Thingiverse and type in 3D Benchy, or you can just Google 3D Benchy. It'll take you to like this website. I just went under download and then 3D files, and then I scrolled down a little bit, and then I clicked on Thingiverse. But you can find this model almost anywhere. It's been posted like in many, many places.
Do you download all the files or 'cause I don't have like the option to like oh wait, okay, wait, you went to files?
Yeah, I went to files and then there's a little download button. I just downloaded the 3dbenchy.stl. There's a bunch of different ones because I
Okay.
think you can do like a multicolor one. But we're just doing single color. So just download the full one.
Okay, got it.
Yeah. But yeah, once you import it into the model, you'll see it kind of renders your part for you. If we rotate around, you can see everything's nice and smooth. But once we slice it, you'll see that it'll look a little bit different. If you ever wanted to change anything for whatever reason, You could change things like the scale over here. So if you wanted to make it bigger, you can, drag these sliders to, make it bigger. I'm just going to leave it as 100% scale today, but that's a good thing to know. Um, you can rotate your piece. So, if the piece, let's say the benchy like imported like this, I could rotate it, and place it in the direction I wanted it to be. The other nice thing is place on face. So if you have that, it'll allow you to select, a face to place it on. So, obviously I'm gonna print it this way, but yeah. Another thing is if you wanted to measure something, you can use the measurement tool and click like 2 points or something. It'll give you like the distance between each other, which is pretty convenient. Um, if you had multiple models, so let's import like another benchy for whatever reason. You see they're kind of like phasing through each other. There's like an auto arranged button, which is pretty nice up here, kind of like the middle of the top bar. So it'll arrange the parts for you. And then you can, delete stuff there, or, just use the backspace button. But yeah, once we have this, our model, I'm just going to slice it for now, just to kind of show you how it works. But then I'm going to go back and start changing some settings. So I'm just going to hit slice. The computer is going to think for a little bit, but then it'll render the sliced part. And this kind of gives you a better idea of how a 3D printer works. So I'm going to zoom in so it's nice and big. You can see uh, on the right here is like a vertical slider, and then there's a horizontal slider on the bottom. So this vertical slider is, kind of allows you to see every single layer. And then the horizontal slider will show you every movement in that layer. So again, how a 3D printer works is it kind of creates or it takes your 3D model, it slices it up in a bunch of little pieces, horizontal slices, and then it will create movement paths um, to make your model. Can you slice again? Yes, I can. So I'm gonna, okay. So to slice, you literally just go here on the bottom right, and then just click slice now. Um, you have to reslice every time you change a setting. So don't worry if you miss that the first time. But yeah, so basically what the slicer does is it takes your model, and then it creates a really long list of instructions for your 3D printer to follow, um, to create your part. So here at the first layer and the first movement command, you can see there's nothing. Um, but as I drag this slider, you can see this arrow representing the nozzle kind of goes along and draws the profile of the first layer. So you see it'll, highlight those letters, it'll fill in all the gaps, and then it'll be finished. On the left side, you can even see like the specific movement command. So this is what your printer will read. So it's a bunch of letters and numbers. So like the G1 command is like a movement command, and then it gives like the printer like a precise position to go to. Once that layer finishes, it'll go up a little bit and do it again, but on the next layer, see this one's a little bit different because there's no letters this time. Fills in over those letters, and then it continues on its way growing and growing until you get your fully 3D printed part. Um, you can also see here, you can see the infill and the perimeters. So right now, just at a glance, you can see that, this is two perimeters. Typically, the one on the outside is a little bit of a different color in the slicer just to represent it. So you can count, two perimeters here, and then this infill's, you know, pretty sparse. So you can tell like the infill is not really high. If I was to change any of these settings, so let's say I want to change the infill to 40%, you'll see like the model just kind of gets, it kind of disappears, or at least part of it disappears. But if I slice it again, it'll re-render itself. Um, so you'll see at a higher infill, those squares become smaller, um, and the print is more dense. You'll also see here on the bottom right, it'll kind of give you some stats on the print, right? So this is mainly what I'm going to be grading off of for this assignment. You'll see like it has a specific weight um, and time that it estimates. It's usually pretty accurate. Um, and, between computers, it's almost exactly the same number. Um, so yeah, when you submit your homework or when you submit this assignment, make sure you get that in the photo in your screenshot. But yeah, now that you all have, a feel for how this slicer works and hopefully how a printer works, I'm going to start applying all the settings for this assignment. So here, um, you know, obviously we're using Prusa Slicer. We're on the Mark 4S. For this assignment, you're tasked to set the perimeters to 3, and then use the 1.5 millimeter or the 0.15 millimeter resolution or layer height at 20% infill with supports on. Typically for Benchy, you don't have supports on, but I'm asking you to turn on supports just so you know how to use it. So I'm going to start with the perimeters. Or actually, no, I'm going to start with the layer height. So I'm going to go over here. I'm going to choose 0.15 millimeter speed. I'm going to discard the old settings I had. So please use the 0.15 millimeter speed. I'm going to specify that there. Because the different settings or the different profiles like speed and structural will yield different times. So please use speed because you use structural, then uh, you'll get a slower time. Obviously, because I changed that setting, my model disappeared because I need to slice it again. If I wanted to see the model like pre-sliced, I can go over here to like the editor view and you can see, it's nice and smooth again. Doesn't have those layer lines. Um, but when I slice it again, it'll be rendered how it would look as a 3D printed part. So I have the layer height set. I'm going to set the perimeters. So I'm going to go under the print settings. I'm going to go under layers and perimeters and then change it to 3 right here. Um, I also want to set the infill to 20% and enable supports. So I'm just going to do it from this side. So I'm going to change the infill 20%, right? Yeah, 20%. Leave the fill pattern alone because if you change that, it can affect the time too. So just change the density. And then I'm going to enable supports. So I'm going to go under support material and then generate support material, auto generated, because that's just what I want. And then with that, I can hit slice. And after a little bit of time and a little bit of thinking, it'll give us our sliced model. So now you see all this green stuff is some more support material that you'd have to remove after you print this to get your final product. Um, you can see here on the left, it tells you exactly how much material you're going to be using for what process. So like you can see here that like support material makes up almost 4 grams of material. Obviously in this case it's not that much, but you know for larger models that can add up to a fairly significant number. Um, Again, for a benchy, you typically don't need supports, but I'm asking you to use it just so you know uh, where to find it. You can also change it here if you were wondering. But yeah, if you followed everything, make sure you know you're using PETG as the material. You should get a time around like an hour 19 or an hour 20 minutes for normal mode. So that's going to be, that kind of time is what I'm going to be looking for this assignment. Does this make sense to everyone? Sweet. Yeah. I realized that I was rambling on pretty early about layer height and perimeters, but hopefully now that you know how to slice things, all those things kind of make more sense. I'm gonna just change some settings, have some fun, just to kind of show you how things can affect stuff. So, if I change like the infill to like 40, it took like an hour 19 before, but now when I slice it, you know, it's an hour 24 now. So, this is a small model, so it won't affect the time like significantly. But, for really large models, this stuff can kind of add up. And it's just stuff that you might want to consider when printing your things. Um, I print Personally, I print things that like can be in like fairly high stress scenarios. I'm part of the Boiler League of Tag. If you're not familiar with that, it's like Purdue's Nerf Club. And one of the things I do there is I print Nerf blasters. So, you know, a lot of strong springs can be put against 3D printed parts, and for the most part, they hold up pretty well. I print like my plungers and stuff with like really high infill, like 100% infill. But you know, they last for a really long time. Some of my blasters have, you know, lasted and never broken at all. So 3D printed parts, even just plastic parts in general, can be a lot stronger than you think. But yeah, that's slicing for you. There's a bunch of other like minute details that you could go into, like tuning, like filament temperatures and stuff like that. But I won't go into that today. This is, just giving you the basics, and this is basically all you need for the most part. Yeah, with that, you should just be able to take a screenshot, and you should be on your way. Um, that's basically it for this assignment. But now I'm going to be rambling a little bit more. Everyone good? I'm going to assume everyone is. Uh, all right. So now that you know how to slice and, get your 3D prints to the printer, um, there are some things that you want to keep in mind um, before printing when designing your model, right? So you saw that like, there's supports and stuff like that that you could use, but you typically want to avoid using it, one because you might be lazy, you don't want to remove supports, and you want to save a little bit of money too. If you can do that, great. And as the designer, you have the ability to eliminate any of these issues if possible. So you can combat these limitations with design. So the first one that I'm going to talk about is overhangs. So I've talked about it a little bit earlier. Um, but basically an overhang is just kind of an angled, uh, like an angled geometry in the outwards direction, from like the wall below it. So you can see here, on the left, this is okay. This overhang is pretty shallow. But as we continue to the right, this angle gets a little bit more extreme, to the
To the
this geometry gets a little bit more extreme, to the point where the print could fail, right? So if you think about, like this cylinder from earlier, this overhang is technically like a 90-degree overhang, right? It's just going straight out perpendicularly. So if a printer was to try to print that by itself, it very likely would not be successful. So typically when I design stuff, I like to limit things at around 45 degrees. Modern printers can usually print a little bit more aggressively. Like I printed, 60 to 70-degree overhangs before. But typically I just like to leave it at 45. It's a nice, even split in the middle of 0 and 90. So, it can make your parts look nice too. Um, Something I like to do is I like to chamfer a bunch of stuff. So, chamfers are typically 45 degrees. So when you chamfer stuff, it'll smooth out the corners, it'll look nice, but it'll also be easy for the printer to reproduce. Um, there's uh, there's chamfers and fillets that could be used. But when I have prints, going vertically, or if I want to kind of like smoothen an edge on the vertical axis, I almost always choose a chamfer, just because it's a 45-degree angle, right? If you think about, um, a fillet, I guess we can go back to, um, this model here. If this cylinder was on just like touching the build plate, um, this cylinder would be, almost like a fillet, right? It has a rounded corner going upwards. But if you think about it, the beginning of the fillet or the cylinder laying on its side is a 90-degree overhang. And as you slowly go up, it'll, be less than 45. Um, but just because how a circle is shaped, the bottom is technically an overhang. So that's why I use chamfers, often, when 3D printing. Small fillets, sometimes are okay, but when you get to really large radiuses, I tend to favor chamfers. Another good example of like a circle being like an overhang is like these internal holes or like horizontal holes. Um, so when you print a circle like this or a hole, um, the top is a really steep overhang, right? The bottom, is supported by everything underneath, but as you get to the top, you're going to be printing in thin air. So for really small holes, it's probably okay. But when you print larger holes, this issue can be exacerbated. So one way I combat this is by adding like a teardrop shape to the top. Um, so I just extend two lines going off of the circle, um, for tolerance or for adding geometric constraints. Um, I like make both of the lines tangent to the circle. I make both of the lines equal to each other. I also make them perpendicular to each other. And then I make like the end vertex of like the two lines vertical to the center of the circle, if that makes sense. So it'll just make sure that it centers this teardrop shape on the hole. And you don't even need to use like a dimensional constraint. You can do all of it with geometric constraints if you've already set the diameter of the hole. So something to keep in mind. The teardrop shape is pretty cool. And for the most part, it doesn't really affect how your part functions. Um, there might be very specific use cases where you may not want to use a teardrop, and you might favor supports, and that's totally fine. Um, but generally, I tend to use the teardrop just so I don't need to have supports. You can see here on the left, it's just a solid circle. This might droop on the top, but if you change it to the teardrop, um, it'll be a nice smooth 45-degree angle all the way to the top. So it makes it easier for the printer, and it might make your life easier later on. Bridging is another big aspect or limitation to 3D printing. It's very similar to an overhang, but it's just a 90-degree overhang from one part of a print to another, right? So like both ends of the model is supported, but the center obviously isn't. So if your printer isn't tuned properly, or your bridge is too long, the filament can start to droop as you print it. So, that's usually undesirable, just because, you want a nice clean part. But if you bridge across a gap, then you'll have some droopage. Um, Obviously, the shorter the bridge, the less likely it is to droop. So, short bridges are probably fine. Um, but when you start to go longer and longer, it gets a lot more difficult. I had a previous student, like I told everyone, please, no large bridges. And then someone sent me like a Golden Gate Bridge. So please don't be that person, right? You know, please don't make me bridge across an actual bridge for your final project. Um, just keep this in mind when designing stuff. Um, my bridging is like decent on my printer, but you know, it can't be perfect all the time. So yeah, if your model absolutely needs to have this bridge, um, one way to fix that is just by adding supports. So you can do that in your model, or I mean, you can do that when slicing. But again, as a designer, if you can design this bridge out, or if you can design a bridge out, I highly encourage you to do so. All right. The next one is just thermal expansion and tolerances. Um, 3D printing as a process, especially like FDM or FFF printing, it isn't the most precise, right? So if you have experience on mills and lathes, people usually talk in like the thousands of inches, right? Smaller than like a human hair, worth of like accuracy. But for 3D printing, the tolerances are usually a little bit wider. That being said, they're pretty decent, and they can get you a pretty functional part most of the time, depending on your use case. But typically, like a tolerance for a 3D printed part being, plus minus like zero point 0.2 to 0.4 millimeters, right? So like if I was to print a cube that in CAD is 20 millimeters cubed, the dimensions one might be like 19.9, 19.8, and then some of other dimensions might be like 20.1, right? So it's a good thing to keep in mind if you're having parts, um, that kind of interface with each other. There's a good chance that you might want to add a little bit of tolerance, by either like cutting away a little bit of material or making something a little bit larger than, um, or yeah, dimensioning something a little bit larger just so things can fit together nicely. And that's just because, you know, as a printer prints your object, um, it'll heat up a material, and it'll cool it down as it exits the nozzle, right? And that heat cycle can like fluctuate the size with thermal expansion just a little bit. So typically for tolerances, for like a 3 millimeter hole, I might add like zero point 0.2 or zero point 0.3, just to get, a nice fit. Um, Warping an elephant's foot is another issue that you might run into when printing. Obviously, it's not something baked into your model, but a physical limitation when printing. Some like materials are more prone to warping than others. But basically, what happens is as the material cools down, it'll contract. And when it contracts, some of those forces might be strong enough to lift parts of the print from the print bed. So you see in this photo here, they were kind of printing this hollow rectangular shaped object, but this corner here has lifted from the base and it's curled up, right? Obviously, that's probably an unintended, uh, you know, circumstance that happened for this person, but it is something to keep in mind. So when printing like really, really wide objects, the chances for warping start to go up a little bit. So, if I was printing, let's say like a chess piece or something, the footprint isn't very large. So, the chances of warping would be, a little pretty low. But if I was to print something like, you know, a sign that I wanted to make, uh, like that was as big as my build plate. The chances of something like that warping are higher than, that chess piece. Um, Obviously, there's some ways of combating that with, making sure your printer is nice and clean, or at least the build surface is clean. But with some materials, that might be something to consider, right? Um, One way to avoid warping is not having like sharp corners. So you can see like this rectangular piece has really sharp corners, and that's where it lifted. But if you have a more like gradual translation or transition with stuff like fillets, if you like fillet every corner of this model, it can combat warping and make it a little bit harder for that to happen. Elephant's foot is kind of like a byproduct of 3D printing. And that's just because sometimes like the nozzle position, especially on the first few layers, might be a little bit low um, than, or might be a little bit lower than what it should be. Um, Sometimes it's to prevent warping, just to make sure, the first layer is like really established well on the print bed. But a byproduct sometimes is that the base few layers um, kind of expand outwards just because the nozzle is squishing the layer um, outwards just to make sure it sticks. So when that happens, you can see from like this circled, zoomed section of this print, you can see the first few layers are like kicked outwards. And depending on your part, um, if this part was supposed to slide and interface with another part, this elephant's foot might prevent that from happening. Um, the way I combat this is I just chamfer the bottoms of almost all my prints. So, chamfering it by like 0.5 millimeters to like a millimeter, can make sure that the outer surface that it might mate to is like the desired like diameter or just size. Because if I chamfer the bottom face and an elephant's foot's out, even with that elephant's foot, that chamfer will probably be smaller than the outer surface, if that makes sense. But a lot of this stuff comes with trial and error, which is why I say like you can, print a couple test prints to just kind of see the abilities of your 3D printer before you design something. And then even, when you design things, some things may not fit perfectly, so you might have to go back, change some tolerances, wiggle them around a little bit, and then you should be good to go. Here's a really good example of like the thermal expansion and tolerancing issues that you might face. So this is a past final. This person made, a Lego style character, but when they went to assemble the the person, the torso didn't go all the way onto the body, right? And in CAD, this probably looked great, right? Like the pegs on the legs probably interface perfectly with the torso. But when you bring it into reality, um, you know, maybe the torso shrank a little bit too much, or the legs, um, or like, yeah, the body shrank too much, or the legs expanded a little bit. Um, and here, the tolerances could have been a little bit looser, and that would have allowed the parts to slide on a little bit more freely. So, if you made those pegs like maybe 0.2 millimeters smaller, then it may have slid on really well. But yeah, that's basically the end of today. Today was a little bit short compared to the other days. There is a quiz, but don't worry too much. A lot of it was stuff that I talked about today, and you have infinite attempts. So this quiz is mostly just to kind of, you know, let you go over what you learned today and just kind of um, help you remember some of these things. So if you want, feel free to take it now. Um, but other than that, that's basically it for today. We're getting out early today. If you want, feel free to stick around afterwards if you have any questions. But yeah, other than that, make sure you do your attendance. Um, and yeah, I'll see you next week.
Thank you.
No problem. You can do the quiz later. The quiz is due like next class.